Okay, I'm going to talk about how I solved the first question about the prediction of population. And first, I think this question is basically the same as the example we talked in the class about the prediction of population. And my solution is to first solve the differential equation first, and then plug in all the numbers to solve the constant, and then I can know the population in every year. So first we write down the differential equation, which is derivative of p is equal to kp times 200 minus p. So as we talk in class, we can just move everything about related to p to the left and keep everything about t, which is time, to the right. And we can expand this bracket a little bit and move everything to the left, which becomes derivative of p over 200p minus p squared equal to pk. And then we can take integral of t in both sides. And we can solve them separately. For the left hand side, we can first simplify the numerator, which it will just become dp over 200p minus p squared. And we need to simplify this denominator based on we learned in Calc 2. It will become okay 200 over 1. I will simplify all the process which is written on the chart. So it will become 200 over 1 over 200, and then p over 1 plus 200 minus p over 1 dp. And then we can solve this integral by taking a ln here, because we know like some 1 over something will become a ln after the integral, minus p, and we need to plus c here, which will become 200 over 1 ln p over 100 minus p. It uses a series of logarithm. And for the right hand side, it is quite simple, which is directly equal to kt plus c. And then we can combine these two equations together. It will become 1 over 200 times ln p over 200 minus p, which is equal to kt plus c. And we can combine the coefficients together here. Then we can simplify this by first I will multiply 200 here to the right hand side. It will become 200 kt plus 200 is still a coefficient, so I will write c here. And we can use the definition of logarithm. It will become, we just use an exponential here, e to the power of 200 kt plus c. And we know like it can be written as e to the power of 200 kt times e to the power of c, which is another coefficient, so it can directly be written as e to the power of 200 kt. Okay, then we can simplify this to solve p, function p of t, which is 200 over 1 plus ce minus 200 kt. Then we can get the relation between the year and the population here. But at the same time, we need to solve the coefficient c and the constant k here, c and k here. And according to the problem, it is given that at 1960, I will set the t equal to 0 here. The population here is, let me see, the population here is 100 million, and the growth rate is equal to 1. Then based on these two equations, we can solve the value for k and c, and it will become and the value of k is equal to 10 to the power of -4, and c, the value of c is 1. Then this function can be rewrite as 1 plus e to the minus 0.02 t. Yes, and as long as we get this equation, we can predict the value of population in every year. So when it goes to 2020, the t will become 60 because it is 60 years after 1960. So we plug in this, we can solve the predicted population is 153.7 million. Okay, and this is the answer for question 1. Then for question 2, I think there are multiple reasons for the difference between the predicted population and the real population. And the first one, I think that is the constant k. I think the k here is something related to birth rate and death rate, but that is not always constant. That's because like the birth rate and death rates will change over time for a city, so this constant k is not a constant. Then second, it is about the migration, because this prediction is only about the growth rate and population in its own city, but in real cases there should be population move from city to city, and this movement will cause a increase or decrease in this city, but it is obviously not included in this model. And for the third reason, I think even though we just consider the city itself, the model itself, like the differential equation itself is too simple. So all these reasons might cause a huge or small difference of the population in this city.